Very good evening, all of you. I hope my voice is audible to you all.
Yes, sir, audible.
Yeah, thank you for sir for the confirmation. So let us start the third day of our data science FDP program. This phone keeps on ringing. Sorry for the interruption. So first day we have covered the theory. We have seen what is data, what is the AI, what are the subset of the AI, what is machine learning, what are the different axes of the machine learning. Then we have seen the some examples of the machine learning application. We have seen the example of the uh, GPT versus Gemini. Then we have discussed the different modules that can be used in Python. And yesterday we have covered the NumPy, which is the numerical Python. In the NumPy, we have seen the 1D array, we have seen the 2D array. We have seen both the things. Now today we will be continuing with the NumPy, and we will be starting with the reshaping of an array. How in what are the different shape in which the array can be reshaped? Then the indexing of an array, conditional indexing of an array, very important one. That, as I have already updated you, we will be going through according to the CS 231 tutorial for the NumPy and the matplotlib, Python NumPy and the matplotlib, which links I have shared in the chat. Okay, so let's start. If you have any if you have any query, doubt in the yesterday session or the day before yesterday session, any doubt or query from anyone, if you have any doubt or query in between, either you can unmute yourself and ask your query, or you can type your query in the message box, Zoom message box. Yeah, just a second. Okay, actually I have deleted all the shells from here. No issues. Done. It's done. Then let me just increase the font size. I hope this will be fine. So let's start first from loading the NumPy. NumPy as NP. NP is the abbreviation that we are using for the NumPy. Like these days, most of the time we people used for making long names shorter. So that is the same thing. Now we have made the 2D array and 1D array, we have also done the time profiling yesterday. We have seen how fast the NumPy arrays are than the Pythonic list. So Pythonic list are extremely slow in comparison to NumPy. And secondly, we have also seen that the loops are also so. These are the two things. So when you are working with the NumPy or in the TensorFlow, it's highly unrecommended to use Python loops or the list. So especially when you are working with the TensorFlow, only and only use the tensors. Even there, the NumPy is also not recommended. Do not use the NumPy function. Do not use the Python functions there. Let us make an example array. Same, I will be making the 3D array of 3 rows and 3 columns. So let's say 1, 2, 3. First row, first column, second column, third column. Let's take it -1, 1, -1. Okay. Then four, 0, 1. Whatever. You can take any random values. Then D type. Let's take the D type as float 32. Okay, let's take the float 32. So now how I can access this one? If I have to access this one, how I can access this one? Or how I can access this 3? So that is accessing a single value. When we try to access a single value, this is called indexing. So I have array. So this is the first row, second row, third row. First row, first column, this thing. First row, second column, first row, second row, first column, second column, last row, second column. So the indexing start with 0. So this is at the 0 index. This will be at the 0 index. This row will be at the 1 index. And the last one will be at the second index. Same is with the column also. So when I write it like 1, that means I am trying to access the first row from this array. So if I want to access the last row, I can also say like this. This it mean the last row. I can say array -1. That will be the last row. Now, if I want this 2, okay, so this 2 is at first row, second column. So this is the 0 index column. This is the 1 index column. And this is the 2 index column. So if I want this 2, then I have to say array. Okay, we can also say print. Okay, this is not first row, this is the second row. Sorry, 1 means the second row. For the first row, we have to say very first row if we want. We have to say array 0. Now This is the last row. We can access the last row. If somebody wants you to access the second last row, then it will be -2. Similarly, third last row, -3. So if I want this 2, which is at the 0 index row, so first will be the row, as we have already seen yesterday also, when we are trying to check the shape of an array. So first thing is the row, second thing is the column. So if I try to print the shape of array, so we can use array dot shape. So that is 3 comma 3. So first is the row, second is the column. Similarly, do not forget to import the NumPy. Okay, remember this thing. And also, getting this thing. Okay, so this is at 0 row, column 1. So it is row comma column. So we are trying to access value at 0th row and 1th column. Now, if I want a particular column, for an example, if I want the one column, so how we can get the this? Okay, there was a network interruption. Let us continue. Okay, so if we have to, I need to reshare this screen. Mm, okay, done. So if we have to access this center column, so mainly if we have to access all values in an column, so direct, it's not like you cannot say that array, if have to access the central column, I cannot say like one means it will be you are trying to access the for one index row, that is the second row, you are trying to access that thing. So that is not this in this way it cannot be done. So to access the column, first you have to tell, first point will be the row, second point will be the column. So first you have to tell colon means to access all the rows, comma, one column. This means all the rows, no starting point, no ending point. This is like that if you want to access all the rows starting from second to last, how we can access that thing? If we have to access last two rows, so how we can say? One way is that we can say 1 colon 3, because upper limit is not included. So we cannot say 1 colon 2. If we say 1 colon 2, in that case only the first index row will be coming, because upper limit is not included in that case. So we have to say 1 colon 3. So you can see here we are getting both last two rows. Now next, similarly, if I don't include the starting and the ending point, that means all the rows starting from the very beginning. Or if I say 1 colon, this means starting from the first index row to the last, whatever will be the last row. And saying nothing, not the starting point, not the ending point, which means start from the very beginning and go to the very end. It's like if we want first two rows. So first two rows, we can say array square braces colon 2. So this will access us the first two rows. If we want last two rows, similarly, last two rows. Last means negative. Remember this thing. Beginning means positive and last means negative. If you want last two rows, we can simply say -2, start from the -2 and go till last. If you don't give the starting point, it will start from very beginning. If you don't give the ending point, it will go to very end. Similarly, if you don't give an starting and the ending point, it will take all the rows. So that's it. What we are trying to say here. Array, no starting point and no ending point. That means the row and the column. What you want? Okay, we want the center column, the first column. So that means all rows of second column. Similarly, we can also do for the column. For an example, if we want the last two columns, so to access the last two column, we can say here last two columns. So all the rows last two column, that means -2 colon. So starting from the -2 means from second last column to whatever up to the last. So these are the different ways of doing indexing and the slicing. So this is an example of the slicing. Slice, same way we have the slice of a bread or a butter. So butter is the some bigger part, we are cutting a part of it. Similarly, our array is a bigger part, we are getting a part of it. So that is the slicing. And indexing to get a single value at a particular point. So these are the different ways of doing the slicing for a row or a column. Slicing and the indexing for a row or a column. You can try this out. Next, we also have the conditional based indexing. So as we have the boolean types, so in the arrays are also are the boolean types. So if I say array, okay, before coming to the this conditional indexing, let us see some mathematical operations on the array. Uh, so if you have an array, I want to find out which values are negative. So in the array, which values are negative? So I can say less than 0. So wherever there is a negative value, automatically it will say they are true, where this condition satisfy. And for the rest of the array, it will say false. So true, true, because there is -1. Here is also -1. Then rest of the thing false, 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 false. So similarly, we can apply all the conditions like greater than, less than, equals to, not equals to, greater than equals to, less than equals to. We can apply all those things, all those condition based operation. They are the elementary operation because they are applying to each and every element. For we have this array. Now when we say array less than 0, so it is this 0 is compared with each and every element in an array. It is also compared with this, 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 this. So it is an conditional based elementary comparison. So anything you can apply if you want to find out the certain values, like where there is a the value is 1, so you can say array equals to 1. So where are the value 1? So 1 is here, so very first we are getting true. Then 1 is also here, we are getting true here also, and 1 is also here, so we are getting true here also. Now based on this condition, if you want to do some type of filtering or the indexing, basically this is a boolean indexing. So if I have an array this, I want all the values which are greater than or which are negative. For an example, if I want all the value which are negative, so I can say where array is less than 0, so this will give me an boolean result. Now I can use this boolean result as an index, so I can just use this thing. This will give an result like this. So wherever value is less than 0, this will return all those value. But in this case, when we are using the boolean indexing, the structure of the array is lost. It will always be returning the 1D array. So by using the boolean indexing, the result is always a conditional array. Sorry, by using the conditional operator, the result is always 1D array. Remember this thing. So this is another way of indexing. First, we have seen the indexing and the slicing. Then we have seen how we can apply the conditional operator between an array and a scalar. This is a scalar because it's a single numerical value. So single numerical value is called scalar. So we can see the conditional operation result between a scalar and an array is another boolean array. the array of books, array of true and false. Now we can also use these result indexing for the index. See here the boolean array here. So this will be what we are doing. We are fitting this boolean array to filter out based on some condition. If I have to find all the even values in an array list case scenario, we are doing the this conditional based filtering in an array that are extremely fast. So let's take an example. We have to find all the even values. So only we have this 2 and 4 which are even. So we can say array. We can apply the mathematical operator. So previously we have seen the conditional operators. Conditional operators. So conditional operator return Boolean array. Similarly, when we are applying the mathematical operator between array and scalar scalar I mean similar same the number. So result is an another array. So if when I have this array, if I try to say array plus 2, so result will be another array where you can see this value 2 is added to each and every value in an array. Like 1 plus 2, that is 3, 2 plus 2, that is 4, 3 plus 2, that is 5, so on. We have all these value updated by adding 2 to them. Now not only we are limited to addition, we can also do the subtraction, we can do the multiplication, we can do the division, we can do the raised to the power, and we can also do the modulus, the remainder. We can also apply the remainder operator there. Now, so our initial task was to find where are the even number exist in an array. So to find wherever the where the even number exists in an array, we can take an array, we can use the modulus sign or the remainder operator by 2. So when you divide the array by 2, so remainder will be either 0 or 1. So if the number is completely divisible by 2, that means if the number is even, then the remainder will be 0. So we can check where the result of the modulus by 2 is equals to 0. It will return an boolean array again because we are applying the conditional operator. Now we can use this array as the index to find where are the even values. So we can say array square braces for the indexing like this. So you can filter out all the even values. Let me just try to store this into another conditional array. I can also say this is even. So is value is even. So this contains that result. And again, we can also use this. Either we can directly substitute, or we can store into a variable, and then we can use that variable for filtering. So this is how you can use the conditional based indexing or the Boolean indexing for either filtering out the values or to checking how many values and of certain condition exist in an array. So we have seen the normal indexing and slicing. Then we have seen the Boolean indexing and slicing. We can even use another array also, or the list, for the indexing and the slicing. Like we have this array. I want this one, and this 0. So there is no relationship in this indexing which we can use. Like this is at 0 comma 0, this is at 1 comma 1, but this is at 2 comma 1. So neither slicing will work here, but we can use the uh, list based indexing here. We can square basis. Then the row, first is the row, second is the column. So which row we want? We want first, second, and third, all the three rows, because from all the three rows we want the variable from first, second, third. So I can say all the rows. Now the values which you want, so we want this. So this is at the, we can pass the list, this is at the 0 index, this is at the 1 index, and again this is also at the 1 index. Okay, here also we have to pass, so from first row, second row, and third row. So this is how you can use for very custom indexing. When you have to do very custom indexing, in that case you can use the either a list of index, or you can also use another array. So if this is an array, if I want some values, I can use another array. I can say array sample equals to np dot array, and in this array I can say I want 0 comma 1, no, 3 is not there, 1 comma 1. Then array, I can pass this sample array here for indexing. Okay, so we can the last thing what I have told you is that when we have to do very custom indexing, let's take another example. Let's take for an example, if we have some big array, np dot array, very big array, 1 2 3 4, okay, then 5 5, 6, 7, 8, then 9, 10, 11, 12. Like this, I have an array. Now, if I want this 2, 7, and 11, so these are the custom index. These are not, there is no relationship in which we can use here the slicing, because slicing used when there is an some sort of relationship or some sort of sequence. So there is a no sequence which we can use to trim down these values from this array. Like if we have some type of a relationship, like if I want this 2, this 4, this 6, this 8, this 10, this 12, like that. So in that case we can apply the slicing. For an example, we can tell the starting point. Okay, start from the 0 row and go till the last. Okay, so last 1 2 0 1 2, so I will be taking is 3, because if I have to use here the 2, then last row will not come because upper limit doesn't include. Then I can tell the step size. What will be the step size? So by default there is a 1 1 1 1, basically step sizes of 1 1. So 1, so first row, then second row, then third row, in that order. But if I use the step size of 2, so that means 0 row, 0 plus 2, that is 2. This 2 plus 2, that is 4. So that so as we have, this will not work. So here today there is lots of internet. Okay, sorry for the interruption. Now as I have told you, I want this 2, this 4, this 6, this 8, this 10, this 12. So first of all, I want all the rows, and from the rows, from the columns, I want this column. So it is starting from the first column, first two till last, first two till last. So here I can say this is column number 0, column index 1, column index 2, column index 3. So here till 4, because upper limit is still not included again. Then we can say colon. Okay, colon. So how much gap I want? I want the gap of 2 2. So I can say here 2. So you can see here 2, 6, 10, 4, 8, 12. So this is how we can do a indexing when there is a sequence in an index. But when there is no sequence in an index, in that case it is extremely difficult or impossible to fetch the value using this custom indexing, using this indexing or slicing, basic indexing or slicing, what we have done in the done with the list. Like if I want this one, this 5, and this 12, so there is no relationship because this is the row 1 and this is the row last. And what I want look, I want one is at 0 comma 0 index. Okay, 5 it as 0 1 row 0 column, and 12 is at fourth, sorry, second row third column. So there is no sequence in this case uh, to access the index while using the slicing. So here slicing cannot be used. So for this we can go to the to passing the index as an to passing an index as an list. So we can say here array, then first uh, what are the index of the rows. So index of the rows, then the index of the columns. Okay. So index of the rows and index, then the index of the columns. So index of the rows are 0, this 0, then this 1. So 1, then we want this 2. So we can say here 2. Next thing, the index of the column. So first this 0, then this second one 0, then this 3. So we can say here 0 comma 0 comma 3. So this is what I was talking about. Anyone? Any other query from anyone? Okay. One more thing, we can also find the transpose. Okay, transpose of an okay, if I have just for the transpose, you can say array dot capital T. This will not change the original array. This will return the copy of the transposed array. Still your original array is same. Okay, still it is same. So I can store it into an array 2. Now I can also use another array to find to get the index or to apply the slicing or the indexing. So let's for an example, if I have array A, which is the np dot array 0, or let's take 2 index, and let's take 1 index and again 0. Now I can use an array A as an index. We can say array 2, then the rows. So we can say the rows like 0 row, 1 row, 2 row, and again 1 row. Then we can use this array. So array 2 is not defined. Just a second. Okay. Actually, I have not executed that shell. Done. So this is how you can see. We can also use another array for the indexing. So indexing is very, very complex. It's required lots of practice. In the case of the NumPy, just what you are just what you are asking is, can you please explain the array 0 colon 3 1 colon 4 colon 2. Yeah, sure. Okay. So here I have an array. First of all, you can also try this thing. So this one, what does I mean by this one? Actually, I was talking that if I have to access uh, this column, this second column, which is at the 0 index. If you see here, this is the 0 index, 1 index, 2 index, and this is the 3 index. And this is the 0 index, this is the 1 index, and at the last, this is the, oops, sorry, just a minute. This is the 2 index. Now I want all the values in column 1 and column 3. That is my target. So how I can access all the values in column 1 and column 3? So first of all, for getting the column, as we want all the columns, okay, sorry, for getting all the rows, as we want all the rows, because we are accessing first and the third column. So we can say all the rows. All the rows means 0 row, 1 row, 2 row. So one way of accessing all the rows is like, just we can say colon. In this way we can also get the all the rows. Or we can say start from 0, go till very end. That is also we can access all the rows. So one way of getting all the rows is just like we can say array colon. This will give also all rows. Another way is that we can give, this is neither we are giving starting point, neither giving the ending point. Okay, we can also give the starting point if you want, 0, and this will be, we have given the starting point from the starting point to very end, whatever will be the, or we can also say colon minus colon. So okay, that will not work. We can say, tell the starting point till the ending point. So upper limit, remember, upper limit or the ending limit is not included. So start from 0 index to very last two. So very last, I cannot say 2. If I say here the 2, it will not include the 2. So this will be from 0 to, in place of saying 0 to colon 2, I have to say here 0 colon 3. So because upper limit is not included, so we have to say 0 colon 3. The best was we have used array colon only. Today network is creating lots of issue. Okay, it's fine. Now next thing is that what I want from column, which columns I want. I want the second column and the last column. Basically, I want the odd columns, 1 column and 3 columns. So to get the odd column, I can say start with 1. So start with first column, and again if I don't give, it will go to very end. It will automatically go to very end. So if I say for accessing the column, if I say, so this is also accessing all the rows, this is also accessing all the rows, this is also accessing all the rows, only in this case, because here we have only 3 rows. So 0, 1, 2, accessing all the rows. Then we want, for an example, if I say 1 colon, Okay. Its internet is back. Okay, fine. It's back now. Yeah, it's back. So why my screen is freezed? It's working fine. So this means starting from the taking all the rows starting from the one column. So that means all this part of the array, this 3 to 4, 6, 7, 8, and 9, 10, 11 will come in this case because we are starting from the very one column. Similarly, as we want 1 and 3, so we can say start from 1 till 4, because if I write it here 3, in that case 3 will be not included, so I can say 1, 4. So coming from 1, 2, and 3, all three columns will be included the odd, so I can say the gap of 2. By default gap is of 1, but here in this case I can say gap of 2. So 1 plus 2, that is 3. In this way it works. So started from one column, 1 plus 2, that is 3. So it will take the 3 column, then 3 plus 2, that is 5, but the third column is not there, so it will, in that case it will not execute it. So this is how we can use this slicing in that case when we have the when we have to access the value, in which case there isn't some relationship. When there is no relationship, in that case we cannot access them. So it's is that clear, or you want me to explain again? Yes, is that clear? Okay, thank you. So let's move further. Okay, so I have showed you how we can use the conditional array or the conditions to for the indexing. I have showed you how we can use the list for the indexing. I have showed you how we can use another arrays also for the indexing. Now let's talk about something about the array math. When we have the two different array, we have seen the maths between the array and the scalar. We have already seen maths between the array and the scalar. For an example, if we have some array x, that is np dot array, let's take in a very small array where something like 1 comma 2, then another this is the first row, then second row is 3 comma 4. So if I say x plus 2, so 2 will be added to each and every value. So in this case, output will be the 3. minus 1, 2 minus 2, that will be the 0. Then we have 1, then we have 2. So operation between array scalar x multiply by 2 will be, in this case, then 3 4 divided by 2, again that will be 2. To the internet is actually internet today is showing lots of disturbance. There is internet is going again and again. Okay, so that is what we have. So if we divide by 2, next thing, if we are raised to the power, if we are applying the power operator, okay, so in that case we can say first modulus, that means getting a remainder. When we are dividing a value by 2, what is the remainder? So 1 divided by 2, again the remainder is 1. 2 divided by 2, that is the remainder is 0. Then the 3 divided by 2, remainder is 1, and 4 divided by 2, that the remainder is 0. Then we have raised to the power. So we can say here in that case 1 raised to the power 1, 2 raised to the power 2, 4, and 3 raised to the power 2, that is 9, and 4 raised to the power, that is 16. Okay, so we can apply each and every mathematical operation. For the mathematical operation also we have built-in functions, built-in method of the NumPy for, like, either we can say array plus 2. Okay, similarly we can also do, we can say array np dot array add array comma 2. So same way, either you do array plus 2 or you say np dot add array comma 2. The execution time of both are approximately same. This is a little bit faster, but usually estimation time of both are approximately same. We can also do the time profiling. I can say percentile time it for the time profiling. I can run this thing. Then I can also say here percentile time it to see the difference between the both, but the execution time of both are approximately same only. There is not much difference between the both. So you can see here the execution time of array plus 2, that is something like 1.4 microsecond, and the execution time of np dot add, that is something like the 1.717 microseconds. So remember, execution time usually is same for both. Either you call it by using some built-in function, um, or you call it directly by using a mathematical operator. So either here also we can say np dot add, we can do by using this function. Then for this we have to say np dot subtract. Okay, you can use the subtract, sorry, subtract. So in this case also execution time will be approximately same. Here it is 2.3 microseconds. Then for the multiply, I don't know why there is so much difference, but usually there is not much difference between the both. Then we have np dot okay, np dot for multiplication we have the product. No, not product, multiply. Multiply. Then for this we have the np dot divide. Then we have the for the modulus np dot mod. Okay, multiply for the multiplication. And for the mod we have np dot modulus array comma. Okay, so np dot mod. For the raised to the power we have the power, that is np dot power. Then we also have some special method, like we have np dot product. Product, this will take only a single array. What it will do, it will multiply each and every element of the array. So it is the multiplication reduced product of each and every value in an array. So we can say the np dot product, that is multiplying 1 by 2 by 3 by 4. Okay, so it will be 6 4 24. Then we have np dot okay, it's not this one. Okay, let leaves for transpose we have np dot transpose also there. Transpose, this can get you the transpose of an array, of the given array. Okay, or you can also use the transpose, or you can use the array dot t, or you can also use the uh, array dot transpose. You can write completely the transpose. All of them will do the transpose of your array. Now to find the maximum and minimum, we have already seen we have array dot sum to get the sum of the array, sum of all the values, or you can also use the np dot sum. For that we also have np dot sum to find the sum of an array, like sum of the x. Either you can call built-in method like array dot sum, or you can call it from the NumPy, either array dot sum or NumPy dot sum, and then you can pass the array. This will find the sum of all, that is 1 plus 2 3 6, 6 plus 4, that will be the 10 in that case. You have array dot max array dot, and this will maximum value 4 in this case. Then you some value, in this case it is 1. Then you also have the mean, x dot mean to get the mean, or you can use np dot mean to get the mean of an array. So I don't know what is the mean. Okay, whatever, you can calculate that thing. Then you have x dot std. Before that, we also have the variance, x dot where. Okay, this will give the variance. Okay, this will give the standard deviation, deviation of an array. Okay, then so these are the some basic operator uh, which we will be using most of the time. So this is between an array and the scalar. Same thing can be also applied between the between two different arrays. Okay, you can say if you want to apply the array maths between the two array, in that case also it will work. So if I have the two array, if I have the array y, that is equals to, okay, we have both array x and array y. Let me just copy paste that array to here. Let us say 5 6 7 8. Okay, I have two different arrays, so I can apply all these functions between an array, all these mathematical functions. I can say x plus y. Okay, so that is equals to that is again, that will be the elementary operations, element wise operation, first to first, second to second. So 1 plus 5, that is 6, 2 plus 6, that is 8, 3 plus 7, that is 10, and 4 plus 8, that is 12. Similarly, when we say x minus y, so 5 minus 1, that is negative 4, 6 minus 2, that is again negative 4, 2 minus 6, that is again negative 4, 3 minus 7, that is negative 4. Okay, and 8 minus 4 minus 8, that is again negative 4. Then we can also apply the product operator. So 5 into 1, that is 5. 2 into 6, that is 12. Then 7 into 3, that is 21. Then 4 into 8, that is 32. Then we can also divide both the things. Again, that will be an elementary operation. 1 divided by 5, that is 0.2. 2 divided by 6, that will be 1 by 3, or something like 0.3333. 3 divided by 7. Okay, that's I need to calculate. 3 divided by 7. So something like this. 3 divided by 7. Then we can also have the modulus. So if we divide 1 by 5, the remainder is 1. If we divide 2 by 6, the remainder is 2. If we divide 3 by 7, the remainder is 3. If we divide 4 by 8, again the remainder is 4. Next, the power. So 1 raised to the power 5, it's 1 only. 2 raised to the power, that will be 4, 8, uh, 16, 32, 64. Something like that. Okay. 2 raised to the power 6, 64. Then we have 3 raised to the power 7. 3 raised to the power 7. So the order matters, which array you take first, which array you take after, because it's not like plus 2, 1 plus 2 is also equals to 2 plus 1. Okay, so not like that, like the negative operator doesn't work, but some operators like x plus y equals to y plus x, x into y, that is also equals to y into x, but x minus y is not equals to y minus x, and x divided by y is not equals to y divided by x. Similarly with the modulus and the raised to the power symbol. Then we have 4 raised to the power 8. So in this way, we can apply between two arrays, but that of same shape. But this is not limited to only same shape. Using the NumPy broadcasting rule, we can apply two different shapes also. When we have array of two different shape, in that case also we can apply these two things. So that is called broadcasting. This happens according to the NumPy broadcasting rule. Like if I take an example of the two array where they have the different shapes. Okay, so where they have the different shape, in that case also it will work if it is based on the broadcasting. Like I have an array x, the shape of x is, so let's take this thing. Now I have an array z. Okay, just a second. The shape of x is 2 comma 2, 2 comma 2. Next we have the this array which has one row but two columns. The shape of this is one row. The first will be the row and two column. Now we have we have the value of one axis is the multiple of the another. Okay, so this row will be broadcasted along the row axis. So this row will be also added to this, and this row will be also added to this. So it will be added to both the rows. So we will be getting result something like this: 5 plus 1, that is 6, 2 plus 6, that is 8, 3 plus 5, that is 8, and 6 plus 4, that is 10. So this is what we have here. So this happens according to the NumPy broadcasting rules. Uh, I can write it here. The row in Z will be repeated along row axis. So basically, the simple rule is that if we have one axis different, so we have to see whether that axis is the of the other another axis or not. So if it is, be repeated to along that axis. So this is a NumPy broadcasting rule. Uh, some more what we have here when we have the mathematical operation between the two array. So we have the np dot product. This is the dot product or the scalar product. Then we have the np dot cross product. This is for vector product or the cross product or the vector product. Okay, we can apply the dot product between the two array or the cross product between the two array. Similarly, what we are doing manually, how we do the manually the dot product between the two arrays, same way we have the np dot dot, then we have the np dot cross also for the cross product. Okay, uh, that's fine. Another one thing more, we can also okay, this is like that, we can also say np x dot dot product dot, okay, dot y, and that is similar to x comma y. Okay, so it's okay. One more thing, here also you can apply the axis also. Okay, so you can also use the axis to get the row wise or the column wise the things. Now any doubt or query from anyone? Any doubt or query? One thing is left is the reshaping. uh, Let me go to reshaping also. That's a small topic. Just give me 5 minutes more. Reshaping. So like we have the thank you very much. Like we have the an array. I have an array. Okay, the shape of this array is 3 comma 4, 3 rows 4 column. So what other possible shapes are there? What other possible shape it can attend? So we can reshape that thing. So for that, you have to consider some, like if we have, okay, reshaping. Okay, when we have the shape like 3 comma 4. So what is the size of this? When we talk about the size, that is the total element. Total element. So total elements are 3 into 4, that is 12. It's contained the 12 elements. What are the factors of 12? Factors of 12. Like into 1D. Okay, this is an array. If I have to reshape into 1D, so I can say reshape. So 1D means only 12 in this case. So you can see here array in 1D. Okay. So when we talk about 1D, so the number itself only in the 1D, that is the 12. When we talk about the 2D, so that means two factors. So two factors. So if we start the factoring of the 12, so we have 1 comma 12, 1 comma 12. That means one row, 12 columns. Then we have 2 comma 6, 2 row, 6 column. Then 3 comma 4, 3 rows, 4 column. 4 comma 3, 4 rows, 3 column. Then 6 comma 2, 6 rows, 2 column. Then 12 comma 1, that is 12 rows, 1 column. Like here you can see 12 rows and only one single column. And again, if we have for 3D, that means 3 factors. So like 1 comma 1 comma 12. So 1 into 12, that is 12 only. Then 1 comma 2 comma 6. Okay. So on, we have multiple. So if you want the things in the 1D, then only the size. If you want in 2D, then you have to find the two factors. If you 3D, then you have to find the, okay. Then if you want in 4D, okay. This today internet is causing lots of issue. Okay. So this is how we can have the one matrices which contains two different matrices. So for one matrices, this is the first matrices, this is the second one. Then in each again we have the two different matrices. So this is the first matrices. In this we have the two different matrices. One is this, another is this, and each of the two matrices of 3 rows. So we have 1 row, 2 row, 3 rows, and 1 column, and this is the 1 column. So this is how you can use the reshaping for the matrices. Okay. So I one topic more there was the copy that we will be looking in the next session. So copy is another important thing. We will be continuing in the next session. If you have any doubt or query, you can ask. Any doubt, query, or question from anyone else?
Sir,
Yes.
from where to we install this Python 3, sir?
Uh-huh. Yes. Uh, what issue regarding the Python installation?
Sir, from where to we install this Python 3 tool, sir?
Python tools. Okay. First of all, in the Colab, these things come pre-installed. If you are using the Google Colab, okay, these things come pre-installed. You can just directly run your code
From browser, we have to do this, sir.
from the browser. You have to execute it in the browser. Any browser you can use, but as it is the Google product, so it's work best with the Chrome. And if you are working locally on this system, then you can install the Python from the official Python documentation that I have already shared in the group. Okay, I can, if you give me just a second, I can just point to that thing again. Okay, I have pointed that thing in the group. So if you want to install locally, that this is the way for
Sir,
installing.
earlier I installed Spider, sir, but it is supported only a few libraries, sir.
No, it's not like that. Actually, these are the ideally, and they support all the libraries. No issues regarding that. It support all the libraries. You can install all the libraries because at the
When
backend.
sometimes when I install like import pandas, at that time it is saying some errors. This library is not supported something.
Okay, might be some issue. But for that, you can search. You can just install the. You can remove all the things. Okay, either you can install the if you are new, I will recommend you to install the Anaconda in that case. If you not want much pain, just install the Anaconda. Okay, Anaconda will make the your package installation very easy, and you can install different packages on the Windows very easily without much pain. But if you are using directly the pip Python package installer, in that case it will be little bit difficult for the new person. So in this case, for your case, I will recommend to install the Anaconda. I have shared the link.
Okay,
You can
sir.
install the Anaconda. Only install the Anaconda, nothing. Remove all the Python packages, remove all the whatever you have installed, the Spider notebook or whatever. Or
Earlier I installed pip3, sir.
okay, what systems you are what OS you are using?
Windows, sir.
It's Windows. So I will
Windows
recommend you
10.
to you go to the this command promote sorry this control panel and just remove all the Python related thing. Either it is the Python itself also, just delete the Python itself also, remove all the Jupyter
Okay.
Python wherever it is installed, and just install the Anaconda with the admin permission. Don't install for the local user, install with the all user and admin permission. Yeah, this one. Okay, actually in this case we are generating an 4D array. We are trying to generate an 4D array where actually for first two column we have the rows and columns. So this is the number of columns, this is the number of rows. So three rows, one column. So of three row and one column, how many matrices are there? There are two matrices of three rows and four column. This 2 means two matrices of 3 rows and 1 column, not 4. Why I'm saying sorry. Here we have the 3 row and 1 column. So this means two matrices of 3 row, 1 column. Next, what does this 2 means? Actually, this is next upper dimension. This means we have another two matrices. We have another two matrices. Each of the matrices contain next two matrices. Each two matrices contain the inner two matrices, and each matrix is of 3 rows and 1 column, like you can see here. So first of all, this very first dimension 2, that means we have two matrices. So you can see here we have the one matrix is this. So overall it is a matrices which contains the two matrices. So first one is first matrix is this, another matrix is this. Then inside each of these two matrices we have another two matrices. Here you can see inside the this is the first one matrices, this is the second one matrices in the parent matrix. So inside the inner matrix we have another two matrices, where this is the inner first matrices, this is inner second matrices, and each matrix is of 3 row 1 column. So these are the 3 rows and 1 column. So this is how it is interpreted. Okay, this is how you can interpret this thing. I can change this thing 1 comma 3. Oh, sorry, 1 comma 2. In that case, I have two matrices. This is the one matrices, this is the second matrices, and each in it there is a one matrix. This is the one matrix, one single matrix of 3 rows and 2 column. So actually, when we are new to NumPy, to imagine multi-dimension matrices, sometimes it is little bit difficult, but with the practice you will be familiar with these types of things. Look, okay, so first query is that you have done PCM. So for the actually we have multiple models. We have the models for building the drugs also. We have models for analysis of the drugs on the different genes. So we can develop the models in which we can use the in which we can use the you can use your this chemical knowledge for the drug development. The drug development can be also done using the deep learning. Okay, so that is the way where as a data scientist, either you can use the result of the different you can use the result of the different drugs on the different parents. Like we have the different mice, we have tested the drugs. Okay, after then we can use that drug data for analysis of that drug on the different mice. Like we can also have the medical data. Like if we are some companies developing two type of drugs, that drugs is tested on the some in some city A, then that drugs is tested in some city B. Then we have the result, like it's a drug for the controlling the high blood pressure, then we have the result. So you can analyze based on that whether the drug is working or not. So these types of things we do in the infernal statistic. We test whether the particular drug is working or not, there is a change in the patient high blood pressure or not, if it's a high blood pressure controlling medicine. So like this, these types of things for analyzing the medical data, because you have the knowledge of that medical or the drug related data. So you can understand better that than a data scientist. So there are different ways of analyzing. As I have told you, using the deep learning also, you can go for the drug development, or you can use these types of data analysis tasks where you can analyze the data of some drug testing results. Okay, so matrices are used in various ways. Like matrices are used in the case of where we have the structural data. Basically, most of the time we have the structural data, so you can, wherever you have the structural data, you can use the matrices. Like as simple as when we are loading an image, the image is loaded as the numpy array only. So in that case, it is if it is an black and white image, in that case it is the 2D or the 3D numpy array. It's depend on how you load it. And if it is a colored image, in that case it is a 3D numpy array. Okay. And most of the time when we are working with the deep learning or the machine learning model, they are based on the mathematical some mathematical background only. So in that case, you have to convert your data into purely into the math, so for into the number in the numerical form. So for an example, if I have in my data, if I have some categorical thing, like if I have the job type, then I have to use the label encoding to convert that into a 0 1 labels. So in that case also, when we are inputting our data into a model, in that case also it is a purely a mathematical array only. Okay, so basically whenever we are dealing with the structural data, we are most of the time we are dealing with the matrices also only. More preferably matrices are the 2D. I can say arrays only, either 1D array or the 2D array or the 3D array. Like we are doing the time series analysis. In that case, we have the 1D array, that is stock price prediction. We have this price stocks. Okay, portfolio analysis also. There also we have the numerical array. Okay, now reshape and the size. Actually, uh, reshaping is changing the shape of an array. Okay, so basically when you are when you have some fixed shape, just as we have seen just now, and you have to change the change into some different shape, then you use the reshape. Okay, uh, then when we are talking about the size, np dot size, it return the size of an array. Okay, uh, in numpy we don't have resize. Okay, we don't have any resize type of a thing. And resize is basically in the case of the images. In the images, basically we have the resize when we have to uh, increase or decrease the size of an array. In that case, we have the resizing. For the resizing, for increasing the size of the image or the decreasing the size of the image, we use different uh, this function, different methods. Thank you for this summarization. Yeah, basically reshaping doesn't affect in memory. Okay, because only was just we are changing the position of the uh, values. Okay, so there is not same memory what is it taking before, it will be taking in next also. Okay, but resizing affect the memory. So if you increase or decrease the size of an array, the size of an image, not an array, size of an image, in that case new pixel are created, or some pixel are dissolved. In that case, the size of an array increase or decrease. in IoT, in image we do the resizing. Actually, when we are talking about an image, like when we are building a classification model, the NN classification model, uh, in that case, actually our model size is fixed, input size is fixed. So in that case, if we have an image of some different size, in that case it is required to resize an image. Okay. uh, but in the case of the reshaping, basically when we go with the IoT data set, or when we deal with the uh, 2D data set, we don't do the reshaping in that case, because we cannot mix features with the samples. Actually, rows are the samples and columns are the features. Like for an example, if we have tested multiple patient, we have gone through some medical tests, we have taken this some medical test of the multiple patient. So the number of patient will be forming the row, and the test what we have done, that will be forming the columns. So columns are the features that tells the property about an sample. Like we are taking the blood test, blood count test, or the patient height, patient gender. So these are the features that is telling about the quality of the patient. So they will be forming the columns. So feature will be forming the columns, and row will be forming the samples. So if we just reshape this thing, if we reshape an data set, in that case the concept will totally change. Okay, in that case concept will totally change, because when we are deploying a model, in that case we might be getting a single patient, and reshaping that single patient will give an ineffective result. So usually in the 2D data set, we don't do the reshaping while building the model. Any other query from anyone else? Okay, so thank you all. That's all what we have for today. We'll be continuing from tomorrow. Thank you all for your cooperation.